हे वेलकम टू द कोडिंग पैटर्न्स। सो आज हम देखने वाले हैं कि किस तरीके से वी कैन सॉल्व ट्री बेस्ड breadth first search patterns, and we will look into it. What is the general idea, what is the breadth first search, and what is the generic solution for it, what the data structure going to be used, and all of it, and we'll solve many of the problems. Okay, let's start without wasting our times. Okay, so tree breadth first search, what it means exactly. So by the tree, you already start able to making sense of a tree, something like this, right? This is a binary tree, by the way. 4, 5, 6, 7, 8. And looks like I'm not following myself or something is happening. Yeah, I think I'm on the wrong board. Let me just reconnect. Okay, so here you can see this is a kind of tree we will be looking for. What it means exactly is, so we will be solving for binary trees only. So binary tree is a tree which have the at max two child, generally known as left child and right child. So if this is a root node, then this one will be the left, this one will be the right child. Okay. And what is the breadth first search? Breadth first search says you have to search the tree in label basis. So first of all, you search at this root and then move to the next level because there is nothing left on this level, particular level. Then you search, you look for this node, then go ahead in this level and then look for this node. And then now nothing is in this level. So again, you move to the next level and move this way. So this is actually a level wise search, level wise search, right? And how to do it, or level wise operations you might say, because we won't only be doing a search, we might be doing some operations also. Now how to do it, in tree generally we use a queue. Okay, this queue is like this queue, and in which use the principle of FIFO, first in first out. Suppose we push 2 inside it, then we push 3, then we push 4. So first we'll remove the 2, then 3, and then 4. So because 2 pushed first, so 2 will remove first also. So how it will help us to traverse breadth wise? Okay, look into that. So suppose we have this tree, 1, 2, 3, 4, 5, 6, 7. And now I want to add all of the nodes, some some all nodes by breadth first search. Okay, so what I'll do, I'll create an array here, and in this array I will be having a, okay, yeah, so all good. So in this array, what I'll do, I push root node, that is 1 first, and then I'll start a while loop. While loop. While loop says while runs. So I'll start a loop that says loop until queue empty. So if anything is in the queue, it will run always. So first of all, we pop the item or dequeue the item. First is current. Okay, current will become q dot dq, and as soon as we dq it, so we'll remove this item. It will become our current item, that will become 1, and it will become empty. But as soon as we dequeue it, what we will do, we push the child of this current to it. So we removed this one, now we push the child of it. So 2 and 3 will move inside it. So first 2 goes in, then 3 goes in. Now, so what I'll do, इसके बाद push the child, push push child, then do operations, whatever operation you are doing on current. Now we are doing current pay operation, like we want to sum. So what I'll do, I'll have a sum equals to 0. Then I will say sum equals to sum plus um, sum plus current dot value. And then now we already did this. This is our loop only. Okay, this is how it will go. And then, and one more thing, do this push child if not nil. If they are nil, then we can't do anything much. If they are not nil, then we'll push it. Okay, good. So let's reiterate it. Now, first thing, sum become 1. Then next one will become will pop the 2, then it will become 2, current will become 2, and then we'll push the child of 2. Those are 4 and 5. So we will push the 4 and the 5 here, and then you will see. Okay, now it moving leftwards. I'm just removing it, and then 2, 3, 4. Sorry, 2 is already removed. Those 3, 4, 5. So now we have these, and we'll do the operation make the sum 3, and then we'll move ahead and pop the q, then current will become 3. We'll remove this and then add the child of 3, that those are 6, 7, right? And if you see, so startingly we started with 1, then we use 2, then we use 3. Okay, let's see what happens next. Sum will become 6. Now, now what I'll do, I'll pop the 4, current will become 4, and then add the child of current. Those are nil and nil, and then add 4 to the 10, then it will become 10. We'll move to the next, for we'll remove 5, it will become 5, add it here, and add the node of 5 nil nil, and then similarly happen to 7 6 nil nil, and then you will see uh, we will add up all of them, 15 and then 6 21 and then 7 28. It, the sum will become 8, then it will start saying nil, and if you having nil, you don't do the operations, and that's our solution. So this is how q helps for breadth first search. Okay, so let's start doing some problem based on it. Yeah, okay, let's start. Okay, so here is the problem that we will going to solve. Given a binary tree, populate an array to represent its level-wise traversal. You should populate the values of all nodes of each level from left to right in separate sub-trees. So what we need to do is, for each level, okay, it's like 2 to 3, we just need to put them in an array like 2 3, and for the first root there is only one. At the last level we have 4 5 6 7, so we will create a new array of 4 5 6 7 and then put it inside this array. Okay, So similarly, if you see this, so at the top we have 12, then 7, 1, then 9, 10, 11. Looks like you got the question. Okay, let's see how we going to solve this problem. And let me follow again. Okay, so here is the problem. Earlier, what was happening is, suppose we have this kind of tree and we were just pushing all of the roots or nodes inside the tree, and then this is a queue that we were using earlier. So we were pushing one by one and the child also. But we how will going to know this level is end? Because we need to know that. Okay. Because we need to create this array for each level. As soon as we get to know, okay, this level is completed, we create a new array, and that's what we want to do. Okay, what can we do is, as soon as, okay, what I'll do is, because we know first node is root, and after that there is nothing else, dash only, right? And now if I say we push the root here, and then we push a uh, negative one value that represents the break. Okay, that represents the break. Negative one value is representing the break, and this is the root value. So if the root value is there, what I'll do? I'll do the normal thing. I'll whatever my new array is. Okay, so suppose I have a result array that will hold the sub array, and this is the sub array that is also empty, and we push it slowly as we move ahead, and we are having the same while loop that says, okay, q not empty, q not empty, and then if uh, if okay, let's get the current बराबर q dot dq. Now we got the current, it is root or whatever it is, and then let me show you how it's going to be work. Yeah, right. dq. I'm start writing this. Instead of that, what I can do, I can show it here. So -1, and now what I'll do, I'll remove this q root from here, and if root is something, then do operations. So there is three condition. If current है तो do operation, do ops. If break है तो if it is break, then add break. If null, don't do anything. Don't do anything. So this is my conditions. Let's see how it plays. So I inserted root here. I pull it, then say, okay, there is two child, just push them. Okay, C1 and C2. Added them. This is C1, this is C2. Okay. Now, did my operations and do everything, then move ahead. This is break. I'll add the break here, and then if you move ahead, and the next one will become C1. Okay, I'll add the child C3, C4, C5. Only suppose these are only present. So it will add C3 and C4. Okay. Then next one it will move to C2. C2 के लिए it will check. Okay, C4 is there. then it will break, then it will break. So now you got it, right? Because we will be adding a break after just the root. Similarly, we will be adding the break just after the uh, end or last node. So whatever the child we will be add of the last node, that the last node of that child will become the last node, right? So that's why this thing will work. Let's how we will going to implement it. Before showing that, let me show you which queue I will going to be used. Okay. Let me show you that. Here I have my cafeteria. See. So here is my queue. I have this node and this way I am using a linked list queue, and here I have this the rear there's the and why I'm not using any inbuilt queue in the JavaScript, because JavaScript don't support any inbuilt queue, so that's why I'm not doing that. So I have enqueue method, dequeue method, peak is empty, and print. I can print the queue itself. Okay, cool. From front to rear. Okay, then let's start writing the code for our problem. Okay, I wrote the solution as we discussed, but there is a problem. Okay, and what is this problem is it stuck into the infinite loop. Why it is stuck into the infinite loop? Let me tell you that. So earlier what we were doing is we were saying ki, okay, as minus one pe what we'll add, if it is a break, then we'll add a one more break. But that is a problem. If you are in a queue and this is minus one and last break. Okay, I'm talking about last break. You reach to the last break. If it is minus one, then you will add one more break. Then it will come to this loop and then one more break. Then it comes to this loop and it comes to this loop, and it will never end. So instead of doing that, what I'll going to do is uh, I won't uh, I won't do this step though. So I will check if there is null, then don't do anything. If there is a current value, if there is a value, then I'll do two things. Do my stuff, whatever I'm doing, and then if peak is minus one, I'm checking. If peak is minus one, then I'll do some of my stuff. My battery is low. Give me some time. Okay, do my things. Now here I'll do my things, and if peak is negative one, if peak is negative one, what I'll do is I will add push one more negative one. And now you will think how this thing will going to differentiate, because I will add here if it is minus one, then break it. Why? If you see this, you were here and you were saying yeah, because there can't be two breaks continuously. We already removed one, and if there is one more, then it means there is something, there is some issue, right? So continuously there can't be two breaks. Okay, so instead of like changing the whole logic, what we can else do also, if peak is minus one in current situation, and then we don't do anything, then we do whatever we were doing, and if peak is also minus one, then we'll break. Right, yeah, that we can do. Okay, let's see that how it's going to be worked. Okay, if current is minus one, then current is minus one. Okay, current printed if q dot peak equals to minus one, then break. Else and q the -1 and do whatever you were doing. Result. Okay, still out of memory. Uh, His peak is not working as expected. The front is there, the front road value. Okay, it should break it, right? Okay, let's see. Give me time. I'm just figure it out. Okay, the solution was hidden inside this thing actually. What I was checking earlier, we were looking for the two continuous negative one. But how can be this next one be present? It won't be. The next one is if the queue is itself is empty, then we have to break it. Else everything was working fine. And now it's done. Let's move to the next question. Okay, cool. So here we have our next question. Next question says, given a binary tree, populate an array to represent its zigzag level order traversal. You should populate the values of the all nodes of the first level from left to right and then right to left. Let me show you the problem. What exactly problem here is. Okay, so my iPad is not working right now. I can show you in this here also only. So if you see, first we will going from left to right, traversing from one, and then storing the values two to three, three to two, and then four, five, six, seven. Okay, similarly 12, 1, 7, 9, 10, 5, and then 17, 20. Now, if you think how we will going to traverse that, we don't need to traverse that way. What we need to do is we just need to store in that manner. So what I'll do is, if suppose we are going from left to right, then we'll push, else we shift. That's what we are going to do in each order. Okay, let's see how we will going to be implement it. Wait, I'll do. Okay, so the here is the solution is the same as earlier. Okay, and instead of this, earlier what we were doing is we were pushing the value inside it, but now we have one more extra variable that called as zigzag. If it is true, then we'll push. If it is false, then we'll unshift the value. So if it is true, then we push at the back. That means we are moving from left to right. And if it is false, then we are adding the element in the front of the array. So that's how it goes. Okay, cool. Now it's working fine, so we can move ahead. So here we have our next problem. The problem is about it's the easy one. So given a binary tree, populate an array to represent the average of the all of its level. So all of its level we have to find the average. So first level ka average is 1, second level is 2 plus 3 by 2, then third level is this. So what we will do is we calculate the sum for first level, and as soon as we reach to the next level we know definitely what will be the length of the next level. Yeah, we know the level size already for this one, so we'll divide it by that level size and then we get the answer, right? Okay, similarly I'll do the sum for them and then divide it by the level size and then I'll get the answer. So that is our average. It is pretty simple. I'm just doing the solution for it right now. Okay, cool. So here is the solution for this. Okay. So what we are doing, the similar thing, exactly same. For loop, we have the level size and everything we have, and but extra thing is level sum. So each level पे we will be adding all of them. So here we will be having the level sum. As soon as we get the level sum, we will be dividing it by the level size, and that will get the average, and then we'll push it to the result. That's it. Nothing more, nothing much. Okay, cool. Okay, let's move to the next question. Okay, so here is our next problem. That problem is about the depth. So the minimum depth in the number of node along the shortest path from the root node to the nearest leaf node. So we need to find the depth of any of the, okay, sorry. So depth of the tree itself. So for this tree, let's say 1 and 2. For this tree, it's 2. For this tree, 1, 2, 3. So any node for which both the left and right nodes are empty, and from that node or from the leaf node to the root node, the minimum distance is the total number of nodes. Those are minimum. Those are called as our depth. So what we will do, we will start traversing breadth first, because for n at any level, though that node can be present. Okay, cool. Let's see. Let's write it down. So here we have our solution. Everything is same. We have a queue, we have a level size, but now we have minimum tree depth. So this for loop runs for single level. So after this for loop, we will add the minimum tree depth to +1, because like all the roots have definitely some of the left or right. Else we have inside this, if any of that level ka left and right both are empty, then we'll say minimum tree depth is +1, because current level we also need to add, because next level is not present but the current level is present. That's why we are adding 1, and then current left is left, and then we are pushing it, and then we are returning the minimum tree. And if you submit it, it is working fine. Cool. So let's move to the next question now. So here is the solution for this next problem where we will be adding this. Yeah. So what I'm doing, exactly the same level size we have, queue root we have. Now how we will be setting it to the next, that is depend on these two conditions only. This is the tradition, we have the current, and if the current is, then we are adding into it, right? Shifting into it. So if it is the last node, that means it will be at the last of the level size. Okay. And if it is I equals to the level size -1, then we'll say next to null. So we have set these things. Now let's simply do. We are here. We already pushed the left or right. That means Q already have the 6, 7, and then next on. So what I'll do is Q ka initially में जो whatever it is, we'll set it to the next. And yeah, that's it. Okay, cool. Let's move to the next question. Okay, here is our problem. In this array, a given problem, what is earlier we were adding here null, but now we don't need to do that. We can add directly this thing, right? Okay, cool. It looks pretty simple than the earlier one. Let's see. And here is the pretty much simplest solution. We don't need to remember the level or anything at all. We are just traversing on the like using this queue. And if there is left and right, we are doing that. If there is length, if queue is there, then we'll adding to the queue's peak, and else we'll set the null. Simple as that. Nothing more complicated here. Okay, let's move to the next. Okay, here we have the next problem. In this problem, what we need to do is, here we have this tree. So we need to store all the nodes of each level, which all the last node of each level. For first level, we have one last node, second level 3, fourth level 4, 7, 6. Similarly, 12, 1, 5, 6. So yeah, so this for this problem we need to have the level size, because we need to know where the this is ending, and then we'll push that into this array. Simple. Okay, so this is the final solution here. We are tracking the level with this level size, and we are pushing the result if the I is at the last of this level, right? And yeah, that's it done. I will be link everything in the description. And thank you.